Okay, we're going to solve the CVPM practice problem using algebraic methods here. We'll use graphical in a different screencast. Okay, so these guys are finding some bikes and they're going to start at the same place and ride away from each other. So I'll just draw them as boxes. I don't feel the need to draw a whole bunch right now. So Creed and Kevin, they're here. That's where they start. And they're going to move with constant v away from each other. We're not sure who's moving faster, so I'm not sure which of these to make to be bigger. But I do know Creed's velocity of 4 meters per second, or speed. And they're going to go away from each other, and then at some point that rope is going to snap taut. And at that point, they are a distance of 8 meters away, because that's how long the rope is. Now that is not a delta x, because no person or object or whatever goes from the left to the right. So that really is just a distance and not a displacement. Alright, so for the individual motions, Creed here is taking some time delta t that we don't know, but in that time he is going a distance of 5.1 meters. And Kevin is taking that same amount of time, so I'm not going to put a subscript on it, but I am going to put one on Creed. He's going a distance that we don't know. The reason I'm using distance here instead of displacement is that the directions are opposite, and we could worry about the vectors and the signs, or we could just look at everything in absolute value because we have a good diagram here. We know what we're doing. Okay, so if I look at what CVPM tells me at the motions, tells me that Creed is going to go that far in his amount of time, and that Kevin is going to go that far in his amount of time. The only other thing that we know is that Kevin's distance plus Creed's distance equals the total distance. Okay, so we're trying to find Kevin's velocity, so I feel free to substitute and eliminate anything other than that. So what I'm going to do is eliminate Kevin's distance by solving for it over here and substituting it in. Okay, so if I look at this equation and this equation, the only unknowns are Kevin's velocity and the time interval. So I can solve for the time to get rid of it. And substitute over here. So d minus dc. Okay, and then I can solve. So I'll try to eliminate the fractions here by multiplying up this. And then divide the dc under. Give me Kevin's velocity. Let me check the units really quick. Okay, so this has units of speed, this has units of distance, and this has units of distance. So when I divide these, the meters will cancel out. I'll just be left with those speed units. So that looks so far so good. Alright, so we know that Creed's going 4 meters per second. We know that Kevin is going 8 meters minus 5.1 meters. And we know that Creed went 5.1 meters, which will give us 2.27 meters per second for Kevin's speed. It really is just a speed and not a velocity, because we ignored the directions here.